Hi, I'm Miss Hearn. If you like this video, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more math videos. All right, another type of sequence that I want to talk about is called, well, the Fibonacci sequence is an example of a certain kind of sequence called a recursive sequence. Who knows? This is the first few terms of the Fibonacci sequence: 1, 1, 2, 3, 5, and 8. Does anyone know how those terms are related, or how would I get the next term in the sequence? The next term in the sequence is going to be 13. Notice that that's the sum of the previous two terms. That's how the Fibonacci sequence works. Each term after the first two, the first term is 1, the second term is 1. After those two, you get every term by adding the previous two terms. So this 2 comes from 1 plus 1, 3 comes from 1 plus 2, 5 comes from 2 plus 3, 8 comes from 3 plus 5, and 13 comes from 5 plus 8. Okay, and we can keep going. And so what's happening is this sequence is defined. Each term in this sequence comes from previous terms. So a sub n, the nth term, is the sum of a sub n minus 2 plus a sub n minus 1, right? So in this case, for example, the 1, 2, 3, 4, 5, 6, 7th term, a sub 7, which is 13, is the 5th term, which was 5, plus the 6th term, which was 8. So we are defining each term in the sequence based on previous terms. That's what we mean by a recursive formula or a recursion formula. Sometimes, given a recursion formula, you can, sometimes given a recursive formula, you can find a way to write it directly where you don't have to have it defined in terms of previous terms, but sometimes you can't. All right, so let's take a look at this example. It says, let a sub 1 be the number 2. Then we're going to define each term after that by a sub n plus 1 equals 72 over 1 plus a sub n. So for example, let's see, we have a sub 1 is 2. A sub 2 is going to be 72 over 1 plus a sub 1, which is 72 over 1 plus 2, which is 72 divided by 3, which is what, 24? Okay, and then a sub 3 would be 72 over 1 plus a sub 2. So that's going to be 72 over 1 plus 24, which is 72 25ths. And then a sub 4 is going to be 72 over 1 plus a sub 3. So that's going to be 72 over 1 plus 72 25ths, which is going to be, what is that going to be? 72 over 97 25ths, which is going to be 1800, check my arithmetic, over 97, which I don't think reduces. And then the 5th one is going to be 72 divided by 1 plus a sub 4, which is going to be 72 over 1 plus 1800 over 97. Are you guys checking for me? Okay, so that's going to be 72 over 1897 over 97, which is going to be 72 times 97 is 6984 over 1897, and so on. One of the properties of sequences is that the limit of the original sequence is equal to the limit if you increase each term in the sequence by 1, to the next term in the sequence. So whether you say the limit as n goes to infinity of a sub n, or you say the limit as n goes to infinity of a sub n plus 1, you're going to get the same result. So let's say, for example, that we were talking about the sequence This is just a side note. This is not this problem. But let's say that we had 1 over x. The limit, if that's our sequence, then actually I should use n's just to be consistent. If our sequence is 1 over n, if I take the limit of the 1 over n's, I'm going to get 0. If our sequence is 1 over n plus 1, then I'm still going to get 0. This could be identified as the term a sub n from the same sequence. These come from the same sequence, just one term ahead, right? But the limit is still the same. Another way of saying that is if you take a sequence and you chop off the first term, like if you take the 1 over n sequence, it starts with 1, then 1/2, then 1/3, then 1/4, and so on. If you take 1 over n plus 1, you're chopping off the first term. So you're at 1/2, 1/3, 1/4. You're still going to converge to the same place, even though you're just missing that first term. It has no effect on the end of the sequence. Okay, so that's what they mean when they say this. Now we're going to use this fact to prove that the sequence, that really crazy sequence that we just found the first 5 terms of, actually does converge. So what we're going to do is we're going to say, okay, let's suppose that it converges, the original sequence, the limit as n goes to infinity of a sub n. If it converges to some number L. So we're going to say let the limit as n goes to infinity of a sub n equal L. Then we're going to see what we can say about the limit of the a sub n plus 1s. Then the limit as n goes to infinity of the a sub n plus 1s, remember this was defined recursively. So let's look at the formula. The formula was 72 over 1 plus a sub n. So that's going to be the limit as n goes to infinity of 72 over 1 plus the a sub n's. Now by our limit properties, we can take the limit of each piece of this, right? We could take the limit as n goes to infinity of 72 divided by the limit as n goes to infinity of 1 plus a sub n. We can also break apart that sum. So this is going to be, let me write it over here, the limit as n goes to infinity of 72 over the limit as n goes to infinity of 1 plus the limit as n goes to infinity of a sub n. But we know the limit of a constant, that's just going to be a constant. So in the numerator there, we're just going to get 72. And in the denominator on the left, we get 1. And then on the right here, this is going to be L. That's how we defined it. Now we're going to use the equality of these two. So we know that since the limit as n goes to infinity of a sub n has to be equal to the limit as n goes to infinity of a sub n plus 1, then it must be that L is equal to 72 over 1 plus L. So we can solve for L. Okay, so that would mean L plus L squared is equal to 72, solving the proportion. And that would mean that L squared plus L minus 72 would have to be 0. That's a quadratic equation. So factoring, we would get L plus 9 times L minus 8 would have to be 0. And that would mean that either L is equal to -9 or L is equal to 8. Okay, but we're starting with positive terms and we're always, we're never subtracting. You're never going to get a negative. So it can't be -9. So it must be 8. Okay, so sometimes when you have a recursive sequence, you can use the fact that the limit as n goes to infinity of the a sub n's is equal to the limit as n goes to infinity of the a sub n plus 1s in order to figure out what it converges to. I hope you found this video helpful. If you did, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Earn Mathematics, for more math videos.